Hello friends, welcome back to Relief Tutorials. In the previous lecture we have discussed about acceleration. Acceleration means the rate of change of velocity. We have a formula A is equals to delta V by T, or also A is equals to V minus U by T. There are two types of accelerations, acceleration and retardation. Acceleration in which the velocity of the particle increases. Deceleration or retardation means velocity of the particle decreases. Note, we have seen the direction of acceleration is always along the direction of change in velocity, not only velocity, change in velocity. One more small thing to understand and then we will see the numericals. Consider this is a straight path. Here the velocity of one of the particle is 2 meter per second. Here the velocity is 6 meter per second. Time required to travel this distance is 2 seconds. One more 2 seconds passed and the velocity now becomes 10 meter per second. And here the velocity is 14 meter per second after again 2 seconds. So we have different observations here. If you see this first pair of observation, initial velocity is 2 meter per second, final velocity in this particular part is 6 meter per second and the time required for that is 2 seconds. So can you find A here? So A is equals to V minus U by T, means 6 minus 2 by 2. Final velocity minus initial velocity by 2. So 6 minus 2, 4. 4 by 2 is 2 meter per second square. Acceleration for the first part. Now look at this part. Second part. What would be the acceleration in that case? So if you think about this part, here was the velocity 6 meter per second and here the final velocity is 10. So here 10 meter per second is final velocity. 6 meter per second is initial velocity. So 10 minus 6 and time required for that is 2. So 10 minus 6 is 4. 4 by 2 is 2 meter per second square. Here the acceleration is 2 meter per second square. Now the last part. In that also if you see the final velocity here is 14 and the initial is 10. So 14 minus 10 and upon time required is 2. So 14 minus 10, 4. 4 by 2 is 2 meter per second square. So this is again what? The acceleration 2 meter per second square. If you see in all this case, can you look at the example again that 2 meter per second is the velocity here, then becomes 6, then becomes 10, then 14. So there is a change in velocity. Yes, but the change is constant. Per second change, the velocity is not constant. Obviously velocity changes. We can see 2, 6, 10, 14. Velocity is not constant. Velocity increases continuously, but the increment per second, the increment in the velocity per second remains constant. So if you see here acceleration is 2, here acceleration is 2, here also 2. So here acceleration is constant. Such type of motion is called as uniform accelerated motion. Uniform accelerated motion. Such type of motion in which, so what is there in the uniform accelerated motion here? Magnitude and direction of acceleration remains constant. If you see, consider the further part. Let me extend the example. Here the velocity becomes 20 meter per second and the time required for that is 2 seconds. Now find the acceleration here. So A is equals to again V minus U, means 20 minus 14. 20 minus 14 and time required is 2. 20 minus 14 is 6. 6 by 2 is what? 3 meter per second square. So here the acceleration is not constant as the previous. So if you have accelerations different from each other, that is called as non-uniform acceleration or non-uniform accelerated motion. So what is there in the non-uniform accelerated motion? Non-uniform accelerated motion in which what? Either magnitude or direction of acceleration is changing, or both. Here in this example, what is the magnitude of acceleration here? 2, and here the acceleration magnitude is 3. So magnitude changes. In our syllabus we will deal with the magnitude only. So these are the two words, nothing much more to understand about this. Uniform accelerated motion means what? In which the magnitude of direction and velocity and the magnitude and direction of acceleration both remains constant. Okay, a formula remains same, everything is same, just the two types of accelerated motion, non-uniform accelerated motion and uniform accelerated motion. One of the question is there on page number 103, blue color question is there. First question, when will you say a body is in uniform acceleration? Okay, so when you can say that the body is performing uniform acceleration? Only when magnitude and direction of acceleration remains constant, and only we can say the particle is performing uniform accelerated motion. And when you can say the particle is performing non-uniform accelerated motion? Okay, so the acceleration in which either magnitude or direction or both are changing, then we can say the particle is performing non-uniform accelerated motion. Okay, now let us understand, or let us see some numericals regarding acceleration. Take out your textbook, page number 103. Page number 103, example number 8.4. Example 8.4. Look at that. Starting from stationary position means initially the particle is stationary. Rahul, let us see the question if you have textbook. Starting from a stationary position, Rahul pedals his bicycle. To attain a velocity of 6 meter per second in 30 seconds. Then he applies brakes. So what is the first phase of motion? Initially Rahul was stationary along with his bicycle. Then he starts pedaling and attain the velocity of 6 meter per second in 30 seconds. Then he applies the brakes such that the velocity of bicycle comes down to 4 meter per second in next 5 seconds. Look at the question. Calculate the acceleration in both the cases. What was the first case? Initially the bicycle and Rahul both are stationary. So initial velocity u is 0 meter per second. Be careful. When particle starts its journey from stationary condition, initial velocity is obviously 0. Then he attained the velocity of 30 seconds. Look at the question. He attained the velocity of 6 meter per second. So final velocity is 6 meter per second and time required to attain this velocity is 30 seconds. This is the first case in which we have to find the acceleration. So A is equals to, formula is V minus U by T. Therefore A is equals to, what is V? V is 6 minus U is 0 and T is 30. So it is what? 6 minus 0, 6 upon 30. 6, 1, 6, 5. So 1 upon 5 means 0.2 meter per second square. This is the acceleration for the first case. Now what is second case? Now he applies the brakes. He started to apply the brakes when velocity was 6. So here 6 meter per second seems to be the initial velocity for the second case, and final velocity, and the velocity comes down to 4 meter per second. It is given in your question, and time required for that is 5 seconds. So A is equals to V minus U by T. Are you getting the question or not? Look at this. Let me draw the condition. Initially the Rahul was here, where his velocity was 0 meter per second because he is stationary. Then his velocity increases and velocity reached to 6 meter per second. And then the velocity reached to 4 meter per second after the brakes are applied. So can you see two phases are there? This is the first case in which the initial velocity was 0, final velocity is 6. And then the second case, you have to consider 6 meter per second as the initial velocity and 4 meter per second is the final velocity, and time required in these is given as 5 seconds. So T is 5 seconds. So A is equals to, put the values and find the answer. V minus U. What is V here? V is 4, minus U is 6, and upon time is 5. So it is 4 minus 6 minus 2 by 5. So it is near about minus 0.4 meter per second square. Here minus sign indicates retardation. Retardation of 0.4 meter per second square is produced. Is that clear? So this is all about the simple application of formula. Let us see some blue color questions given on page number 103. Blue color question number 1 already we discussed recently. Now blue color question number 2, page number 103, blue question number 2. Look at this. A bus decreases, it's directly given, a bus decreases its speed from 80 km per hour to 60 km per hour. So bus was initially traveling with 80 km per hour speed. So initial velocity we can say U is 80 km per hour, and 80 km per hour, and final velocity is given as in the question is 60 km per hour. And this change taken place in 5 seconds. So T is 5 seconds. Find the acceleration of the bus. Simple question, you have to find A. We have a formula. So A is equals to V minus U by T. Therefore A is equals to, what is V? V is 60, but I have told you that whenever you are finding the acceleration, you cannot keep unit of velocities as kilometer per hour, because acceleration is only having a one unit, and that is meter per second square or centimeter per second square. So you have to convert this kilometer per hour into meter per second. In the second or third lecture we have discussed that whenever you want to convert kilometer per hour to meter per second, you have to multiply that number by 5 by 18. Okay, so 6 3s are and 6 10s are, so 10 5s are 50, 50 by 3, 50 by 3 meter per second. And here in 80, so it's 80 multiplied by 5 by 18, it's 80 there, so 2 9s are, and 2 40, 40 into 5 it's 200, 200 by 9 meter per second. So initial velocity is 80 km per hour, but we have converted that into meter per second. It's 200 by 9 meter per second. Final velocity is 60 km per hour, but we have converted that into meter per second, and that is 50 by 3 meter per second. Time is given as 5 seconds. What is A? A is equals to V minus U by T. So that is A is equals to V. What is V? V is 50 by 3 minus U. U is what? It's 200 by 9 by T. T is 5. So A is equals to, now if you see here 3 and 9, you have to subtract this, so take the LCM of 3 and 9. LCM of 3 and 9 is 9. You have to multiply this number by 3. So 3 here, the 3's are 9, and multiply by 3 here also, the 50's are 150. So it's 150 minus 200, and that is divided by 5. Now 150 minus 200 is minus 50, and this 9 goes to denominator, so 9 5's are 45. Okay, so now 5 9's are and 5 10's are, so minus 10 by 9. So acceleration A here is minus 10 by 9. Now if you want to convert it into decimal, it is 9 1's are 9, so it will be minus 11.11 or minus 11.11 meter per second square. This is the acceleration. It's actually retardation. Blue color question number 3. Please read that question. A train starting from a railway station. A train starting from railway station. So obviously, if the train starting from railway station, it was initially stationary. So initial velocity for this, you can say u is equals to 0 meter per second. moving with uniform acceleration, attains a speed of 40 km per hour. Means attain the speed of 40 km per hour in 10 minutes. Time required for that is 10 minutes. Find its acceleration. The train starts, whenever you see, students, whenever you read the question, you have to make a list of data. While reading the question, you make a list of data which is given to you. And now the question is to find acceleration. Initial velocity is 0. Final velocity is 40 km per hour, but we have to convert this 40 km per hour into meter per second. Multiply it by 5 by 80. So it's 2 9's are and 220. So it's 20 into 500. So it is 100 by 9 meter per second. And here the time is given in terms of 10 minutes. You convert it into second compulsory. So 10 into 60 will be 600 seconds. So don't be in a hurry. First of all, you see the units and match the units, meter per second and second. Then only you will have your answer of acceleration in terms of meter per second square. So A is equals to V minus U by T. Therefore, A is equals to, what is V? V is 100 by 9. Minus U is 0. So no need to write minus 0. Upon T. T is 600. Transfer this 9 in the denominator. So A is equals to 100 by 9 into 600. So 2 zeros will be cancelled. So 9 6 are 54. So it's 1 by 54. One by 54 meter per second square. Since for such a complicated fractions, no need to convert it into decimals. That is okay here. So this is all about the numericals regarding only acceleration. Next topic is totally different. Up to here in this chapter we have seen distance, displacement, speed, average speed, constant speed, then velocity. and then acceleration. These are the main points. Many subtopics also we have discussed. These are the things we have discussed. Here is the end of all the characteristics can be measured which is connected to motion. But now the topic is how we can represent this thing by graph. How we can represent all these characteristics of motion with the help of graph. So the next topic will be about the graphical representation of motion. Till then, keep practicing, solve these blue color questions and also the questions we have seen from the exercise. Best of luck.